and the masters of the universe. I am Adam, Prince of Eternia and defender of the secrets of Castle Grayskull. This is Cringer, my fearless friend. Fabulous secret powers were revealed to me the day I held aloft my magic sword and said, "By the power of Grayskull!"
Okay, so we're looking at Unit 7, Section 1. We're talking about exponent properties, which are powers. And He-Man is the most powerful man in the universe, besides Mr. Kelly, because he knows his exponent rules. And if you remember, exponent rules takes us back to algebra. It's Unit 9. That's where Brust introduces these, 9.1 through 9.3. And that's where you treat your numbers like numbers. That's what Brust treat numbers like numbers. That's about the most confusing thing I think I've ever...
Squaring everything in here. That? So when I go x to the 6, that's not a problem to see. X to the 6 squared, I multiply times 12. But what about this? This is actually still negative 10 squared. So I took care of that. You got to square everything, though. What is negative 10?
Anyways, so what I'm going to do is go through these rules quickly for you. I'm going to be quick. I'm going to go through them fast, and then we're going to do some examples because it is review. But if you need more help, 9.1 to 9.3. All right, so let's look at the first one. It's called the product of powers. Basically, if you have a common base, remember the A is called the base. All right, and the exponent is up here, sometimes called the power. If the bases are common, then when you multiply two common base terms, then you just add the exponents. What does that all mean? Well, if you have 2 to the 10th times 2 to the 12th, all right, what's that going to equal? Well, you have 10 2's here and 12 2's here. All right, so you need to add those together. You're going to have a total of 22 2's. That's a lot of 2's. All right, it works the same way for variables as well. So if you have x to the 7th and you multiply it times x to the 5th, all right, you have 7x's, and then you're multiplying by 5x's. If you put them all together, that's going to equal 12x's. So the rule is you just add them. All right, well, what about the opposite of that, the inverse? Well, the opposite of multiplying is dividing. All right, so the rule stays the same basically, except you're still doing the inverse. The opposite of adding exponents is subtracting. So if you have, I'm going to start with some variables this time. If we have x to the 12th and we're dividing out, I think of it as dividing out x to the 5th. All right, what does that mean? You have 12 x's on top. X, 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 x. You have 12 of them on top, but you have 5 on the bottom. 5 on the bottom will cancel 5 on the top. They'll cancel out. Okay, just like when we reduce fractions, same thing. So if they cancel, you're going to be taking 5 of them away on top. So what does that mean? Well, that means that the rule is you just subtract the 5 from the 12 and you'll get x to the 7th. Okay, it works the same way if the base is a number as well. All right, the next one, the power of a power. This is where you take a base that's raised to an exponent and you raise that whole quantity to a higher exponent. So an example of that would be, let's go with 5 to the 4th, and you want to raise that to the 3rd power. That means you have 3 5 to the 4ths total. That's hard to say. You have 3 5 to the 4ths. So you have 5 to the 4th times 5 to the 4th times 5 to the 4th. Well, using our product of powers rule up here, that means you can just add the exponents. It's 4 plus 4 plus 4. All right, that's going to give us what? That gives us 12, but the shortcut is you can just multiply those. All right, so all this equals 5 to the 12th. So whenever you have powers raised to higher powers, then you just multiply. That's the easy example for that one. Now, where students get tricked up is the power of a product. If you have two terms being raised to a higher power, it gets tricky, especially when you look at this. Well, let's look. 12x to the 5th, and you raise that to the 3rd power. All right, where students mess up is with that 3rd power, it's got to go to both terms. The 2 is separate from the x to the 5th. So that 3 has to be applied to both of those bases. So what is this going to give us? This gives us, remember, if there's no exponent, there's really like a 1 right there. So it's 3 times 1. The rule is you multiply here. So it's 2 raised to the, 3 times 1 is 3. And then x raised to the 3 times 5 is 15. Okay, so that's going to be our simplified form. Well, not really. We could take 2 to the 3rd power, that's 8. So let's do that. Let's call it 8x to the 15. And that would be the final simplified form of this problem. So students, what I see students do all the time is they just multiply the 5 times the 3. They forget about that 2, that coefficient out in front. So make sure you don't do that. All right, power of a quotient. Same idea. You have to raise both the numerator and the denominator to the exponent when you have a fraction that's being raised to a higher power. So an example of that, if we have x to the 4th over y to the 5th, and you raise that whole quantity up to the 6th power, that 6 has to go to the numerator and it has to go to the denominator. So what is that going to give us here? It's going to give us x to the 24th all over y to the 30th. All right. Now you might ask, why does this rule work? Okay, this rule works because you have 6 of these fractions, so you could line up 6 of them, 1, 2, 3, 4, 5, 6, and then it's the same rule. It goes back to the product of powers rule. If you have 6 of them side by side, you're going to have 6 4s and you're going to have 6 5s. That's going to give you 24 and 30 respectively. All right, last couple. We have negative exponents. If you forgot what that means, if we have x to the negative 5th, that's going to equal 1 over x to the 5th. That means that you take that exponent, you bring it downstairs. I always tell my students it's like upstairs and downstairs. This guy's upstairs. If you go downstairs, you change the negative to a positive. That's the definition of a negative exponent. All right, so where students get in trouble, well, we'll do examples in a minute, but students get in trouble, you get 2x to the negative 1 times y to the 3rd. The only term that has a negative right here is the x to the 1st. All right, so that x would come down in the bottom, and that would equal 2y to the 3rd all over x. I just realized x to the 1st. I realized that it looks like those two are together, but they're not. They're separate problems there. Last one, 0 exponents. Anything to the 0 power is 1. Anything. So if you have 5 to the 0 power, students will, their gut reaction is to put a 5 down, but that's actually equal to 1. All right, so you can have like x to the y over z, get it ugly, raise that to the 0 power, that'll all just equal 1. Alright, so hopefully that makes sense for you there. Don't combine those two there, I don't want you to be confused later. Let's look at some examples now. Alright, so 5, basically it's the same rules for the whole, same directions for the whole assignment this time. We're just going to simplify. So we have to know what simplify means. It means use only positive exponents, and if you can figure it out, go ahead and figure it out. And then it asks, what rule did you use? All right, so first one, we have common base, and they're side by side. So this goes back to the very first rule we have, the product of powers rule. So that's going to tell us we can just add those exponents. So we're going to get 5 to the, what's 5 plus negative 3? 2. All right, now I'm going to simplify that, and that's just going to equal 16. I like 16. That's an easy answer for me. You have to simplify. It says simplify. I would if I could. All right, another way you could do it. This is way number 2 to do it. I'm going to show you a couple different ways because there's no right way necessarily as long as you get the right answer. Remember that if you have a negative exponent, that means you can go downstairs. Okay, it means you put yourself in the bottom of the fraction, but you change your negative to a positive. So this is the same as 4 to the 5th over 4 to the 3rd. Okay, so what does that mean? Well, here we have the, which rule is it? Let's go back and look. It's this one right here, quotient of powers rule, where the rule is you subtract your exponents. If we do that, 5 minus 3 is 2. Okay, and that's going to give us our 16 the same way. So there's 2 ways to do that one. You don't have to do it either way, but you do have to show your work and show us which way you did it. You don't have to do it either way specifically, I should say. All right, next one. What's the difference between 2 and 3? Look at them. 2 and 3, what's the difference? Okay, one of them has parentheses, one does not. So hopefully by now your teacher's been harping at you. You want to use parentheses around your negative numbers if you're plugging into expressions. That's really important, and this is the reason why. We go back to GEMDAS. You have to do exponents before you multiply and divide. Right here, see that negative? All right, it's not negative 3. It's a negative term. It's a negative thing. It's a negative 3 squared. So that means you have to figure out 3 squared first, and when you're all done, you make it negative. That's different than number 3 here. Number 3 says we have negative 3, and it's that number squared. All right, so I'm going to say that again because it's really important. Number 2 is a negative term. It's negative blah, whatever this thing is right here. Negative 3 squared. It's going to be negative 9. 3 It's the number -3, and that's why we use parentheses. It's that number squared, so it's going to end up being +9. So for those reasons, you have to be very careful when you're using negative. This is going to equal -9. This is going to equal +9. And I just talked you through it twice, so hopefully you're good with that one. All right, let's look at number 4. By the way, before I get a bunch of hate mail, no rule that I taught you did we use for this one here. So these are just, I'm just reminding you about our order of operations there. So no specific rule used there. All right, back to 4. Sorry. All right, we have -2x, and that quantity is raised to the second power. So remember, that 2 has got to go to both the -2 and the positive x. All right, so what's that going to look like? That's going to look like, here's the -2. That's going to be raised to the second power. Here's the x. That's going to be raised to the second power. Why don't I put parentheses around the x? You can if you want to. I do it around the 2 because it's negative. And I'm trained. Whenever I have a negative number and I'm going to square it, I put parentheses around it. That makes it really clear to everyone. So with 4, what do we have? This is -2 squared is 4. X squared. Done with that one. What's the rule? Let's look back. Which rule do we have? We have an exponent going to 2 different terms. Where would that be on our chart? That would be right here. Yep. Power of a product rule. And we're just going to call that the power rule. Whenever you have an exponent, by the way, we're just going to call that the power rule. Okay? Sorry, whenever you have an exponent to higher exponents, we'll call that the power rule. We're always dealing with exponents in this chapter. All right, 5. With 5, look at that negative. Again, this is an order of operations where that 6 is only applied to what's in the parentheses. It is not applied to the negative. So I know that when my answer is done here, it's negative something. My answer is going to be negative. Okay, it's not going to be positive because there's 6 of them and they cancel out or anything like that. That 6 only goes to the 1x. Okay, so what am I going to do? That means it's going to be negative, and now let's figure this part out. 1 to the 6th power and then x to the 6th power. All right, well, what does that mean? We have -1 x to the 6th. Well, that's what your answer is going to be. Okay, you can't simplify any more than that. That's going to be the power rule there as well. How about 6? Okay, that 2's got to go to both, up top and down low. Here's where we're tricky, okay? It's going to be 3 to the 2nd power all over 4x to the 2nd power. That's crazy. Blow your mind because now that 2's got to go inside both of those parentheses there. So this is going to equal, what's 3 squared? Well, that's going to equal 9 over 4 squared x squared. Wow, craziness. So we get 9 over 16x squared. That's going to be final answer. Can we simplify that fraction? No, we can't, but we should check it. What rule did we use? We used a couple there, quotient rule, and we used the power rule. So, wow, that's fun stuff. Let's go to 7. Whew, it's getting ugly now. So the first thing I see that we can do here, we have a couple of D's up here. We can put those together. Remember, we have to follow our GEMDAS, so you have to do order of operations. And the division bar here is a big grouping symbol. That means that we have this whole thing in the top. We could actually simplify that if we wanted to. So I'm going to do that first. I'm going to call that 12d to the 7th and then f all over 3f to the -1. All right, so now next rule, I'm going to see that 12 and that 3. Let's cancel those out. All right, so 3 goes into 3 once, 3 goes into 12 4 times. So I'm going to rewrite this the way we have it now. We have 4d to the 7th times f all over f to the -1. Now, what's our rule? Let's go back and look at our rule for negative exponents. Rule for negative exponents says that if you have a negative exponent, you can put that base in the bottom if you change the negative to a positive. Well, you know what? It works the same way. If this is positive, it can go in the bottom and be negative. And that means if it's in the bottom and it's negative, you could pull it up top and make it positive. The rule is very simple. If you go from top to bottom, you just change it from positive to negative. And we never want negative exponents, not when we simplify. So what we're looking at here is that f to the -1. What I'm going to do is I'm going to take that term and I'm just going to bring it up top. And when I do that, I'm going to get 4d to the 7th f, that's this f right there, and then this f comes up as well. So we have f, this is to the first power, so we have 2 f's to the first power, and they're being multiplied by each other. How can we simplify this? It would be 4d to the 7th f squared. Wow. Fun stuff. Let's do number 8 now. What do we have? There are no powers being raised to higher powers, so that's nice and easy. I'm going to look at this. I'm going to say, well, let's take the coefficients. Remember what Bruss said, treat numbers like numbers. Fantastic. So we have 6 times 4, which is 24. We have g to the 5th times g to the 1st. Which rule is that? Let's go back and look. That's this rule right here, product of powers. I just call it the product rule. All right, so the product rule says we have 5 and 1. We're going to multiply those two terms, and to do that, that means you add exponents. Wow, 24 g to the 6. It's getting crazy yet? Wow, crazy. Let's look at 9. We have, I immediately see z to the 0 power. Now, what I'm going to do, I'm going to cross that thing off. Why? It's not equal to 0. It's equal to 1. So you have 1 times all this stuff over here. I don't need to write the 1. So that just made my problem a lot easier. Then I'm going to take this negative 4 term and I'm going to move it downstairs so that it changes from negative to positive. So what am I going to be left with? I'm going to have 5x all over y to the 4th. And that's because that guy moved downstairs. All right, when it moved downstairs, it became positive. But don't forget, this whole term is being raised to the 3rd power. Okay, so now what do we do? That 3's got to go to the numerator and it has to go to the denominator. So that means we're going to get, and be careful here, it's not 5x to the 3rd, it's 5x the quantity, the whole quantity 5x to the 3rd power. And that's all over y to the 4th, and we're going to raise that to the 3rd power. That's going to give us y to the 12th. So how does this simplify? Well, that 3's got to go to both now. So we're going to get 5 to the 3rd, x to the 3rd, all over y to the 12th. Whew, almost done. What's 5 to the 3rd? If I were doing this, I could figure that out. 5 squared is 25. Add another 5 there. You get 125 x to the 3rd, all over y to the 12th. That is a crazy difficult problem, but we have more. Should we take a 5-second break to get our heads in the game? Let's do that.
And he tries. Oh my God, do I try? I try all the time in this institution.
I love YouTube. You can find anything on there. All right, let's look at number 10. 2 ways to do it. I'll show you the 2 different ways. First way, let's move that v to the minus 2. Let's move that up. Look, common base here. We have v to the 6 and v to the minus 2. Let's move that upstairs. And you know when you move that upstairs, that negative 2 becomes positive 2. Let's reduce that fraction. So a 5 comes out of 5 once, out of 15 3 times. See how that works? So on top, we get v to the 6, v squared. That's going to be v8. Drink that up, baby. On the bottom, we get a 3, and remember that v to the negative 2 went up, so it's no longer there. So we get v to the 8th over 3. That is the final answer. Let's do it the other way. The other way is using the quotient rule, where you subtract. And we still have to reduce this, so that's going to be 3 and a 1. All right, so we're going to get 1 over, there's a 3 in the bottom. The rule is 6 minus negative 2. 6 minus negative 2. That's the quotient rule. You subtract, right? I don't like to use that because students usually forget that other negative there, but this also reduces into v to the 8th over the 3. I think I like the first way better. Let's look at 11. Okay, with 11, I see a whole bunch of x's here on the inside. What else we got? Y's. Let's put those together. So, parentheses, what do we got? X to the 3rd, x squared. The product rule says we just add those exponents. We're going to get x to the 5th. Same thing for the y's. We're going to get y to the 9th. That whole quantity is squared. Remember that 2's got to go to everything, including the 4. So we're going to get 4 squared, x to the 10th, y to the 18th. What is 4 squared? It's 16. I can drop those parentheses, and we're going to get 16, x to the 10th, y to the 18th. Done with that one. All right, let's look at 12. This is a little interesting fellow here. It's very similar to 10, where we have like bases on top and the bottom. Let's fix that. Let's first reduce our fraction here. I'm going to worry about that cube later. Let's reduce that fraction. So if I reduce that, what can I take out of both? Probably a 4. What's that going to leave me? Leaves me a 7 on top. Leaves me a 2 in the bottom. All right, that's not going to reduce anymore. Let's take that y to the negative 3 and let's move it up. Moving on up, moving on up. All right, so what do we got? Y to the 5th, y to the positive 3 because I moved it up. On the bottom, we have a 2. That whole thing's still raised to the 3rd power. Let's simplify a little bit more. So we're going to get 7y to the, product rule, 8th. And that's all over 2. And now we have to cube this. Wow. This is amazing stuff. So that cube's got to go to both the top and the bottom of this fraction. Well, if we put in the bottom, that's easy. That's going to be all over 2 cubed, right? In the top, you got to remember it's got to go to both of those. So we're going to get 7 to the third y to the 24th. Almost done, peeps. 7 to the third power is 343. We get y to the 24th. That does not simplify anymore. All over 2 to the third. That ain't 6. Call it an 8, and we're all done with that. Whew! That was crazy. That was crazy. Numbers 13 through 15 have been specially crafted just for you to try on your own. Pause the video. Let's do it. Pause the video. Okay, I didn't just flash the answers up because I want to take you through my thought process. So what I'm going to do is do some highlightation. I just made that word up. There's some highlightation. The negative exponents. I hate those. So let's move those so they're not negative anymore. So I'm going to keep the 26, the 4, and the x over here. 26, 4, and the x. But I'm going to move these other terms so that they're positive. So x to the negative 1 goes downstairs, becomes x to the positive 1. Y to the negative 3 becomes y to the positive 3 on the bottom. And y to the negative 2 in the bottom comes up top. Okay, and becomes y to the positive 2. So now I'm going to simplify. We get 26 over 4. This could be simplified here. What do we got? 13 over 2. What are we going to get? 13 over 2. We get a y squared. And on the bottom, that's really an x squared, right? We get x squared y to the third. Okay, so now we're at the point we're almost simplified. We have y to the squared on top. We have y to the third on the bottom. A couple different ways you can do that. You can move the y squared back downstairs if you want to make it negative 2 and add those. You'll get y to the first. Or the way I like to think about it is, let's look. Y squared means you have 2 y's. Y times y. On the bottom, y cubed means we have y times y times y. There's 3 y's. 2 of these guys are going to cancel 2 of these guys. It's just going to leave 1. So if you want, you can cancel this with 2 of those, and it leaves a 1. Final answer. 13 on top, nothing else. On the bottom, 2x squared with 1y. There's 13. Now, there's a couple different ways you can do it. That was my thought process. Let's go on to 14. You can check with your teacher if you want to see if maybe you did a different way, if it's still valid. Okay, so I'm looking at 14. I want to take you inside my mind. That is just a crazy place to be. I see this negative. I'm going to work this out here. That's negative. Let's bring him downstairs. I'm not going to change anything else. So we get 3b to the 5th. That's all over. 4, that was a to the 3rd, b to the 4th. That was there, and now I'm bringing that a to the negative 3. Bring it downstairs, becomes a to the positive 3. The whole quantity is going to be squared. All right, can I simplify this a little bit? 3b to the 5th, all over. Let's put those a's together. Let's combine those using the product rule. All right, so we're simplifying this a little bit more and more. On the top, we have 5 b's. That's what that means. B times B times B times B times B. There's 5 of them. On the bottom, there's 4 of them in the denominator. I could take those 4 and cancel out 4 on top, and it leaves 1. Right? That's how I think about it in my brain. I'm going to get 3b to the first all over 4a to the 6, but that whole quantity is squared. I'm going to go back and talk about that again. You have 5, this is what we have, b to the 5th over b to the 4th. Essentially, that's what we simplified. You can use the quotient rule and subtract. That'll give you, remember the quotient rule says you subtract exponents. Whew, trouble getting that out. You could bring the 4 up top and make it b to the negative 4. Then you can add using the product rule. Okay, or you can do what I did. Common sense. You have 5 on top, 4 on the bottom. The 4 on the bottom will cancel out 5. They'll leave 1s, times 4 1s, but we don't have to worry about that because there's other stuff there. All right, on to where we were. We get 3b over 4a to the 6th. That whole quantity squared. Remember, when you square a fraction, you got to go top and you got to go bottom. And when you go top, you got to go to both terms. You got to go to the coefficient. We're going to get a 3 squared. You got to go to the variable. You're going to get b squared. That's all over. Same thing on the bottom. 4 squared and then a to the 12th. Final answer, if we could simplify this thing, we get a 9. B squared all over 16 a to the 12th. This looks like Sully's jump shot. Whew, if he doesn't warm up, ugly. As opposed to when he does warm up, even uglier. Number 15, 0 power. Anything is 1. Bummer if you work that out. You should check for that. Anything is 0 power is 1. All right, that is it. Whew. I am sorry that those are all messed together, but that's what you're going to have to do. Be able to take different problems and separate them into, easier problems. Use whatever rules you want to get to the most simplified form of each term, but hopefully it works out for you. I know exponents were a big challenge in Algebra 1, but I'm confident you guys can handle it. Hey, this is Mr. Kelly Baumholder. Remember, it's nice to be important, more important to be nice. Let's watch a little more He-Man.
And so I cried sometimes.